Hello friends, myself is Sachin Kumar. In this video, I am going to discuss about all pair shortest path problem, and this algorithm is based on concept of Floyd algorithm, Floyd Warshall algorithm. If we talk about the all pair shortest path problem, then we have to find out the shortest route between all the pairs, all the pair of the vertices. Here, graph may be negative. Negative bits are allowed. Negative edges are allowed. Floyd-Warshall algorithm is managed to handle negative bits. Negative bits edges are managed here. If we talk about the procedure of Floyd-Warshall algorithm, then this procedure is very easy. We have here one formula, and this formula is used to solve Floyd-Warshall algorithm. Formula is given here dkij. I mean distance from I to j, and k here number of intermediate vertices. Up to k we have here intermediate vertices. Say if we talk about this k, then values are here 1, 2, 3 up to k. 1, 2, 3 up to k are here intermediate vertices, and this is given by minimum dk minus 1 ij, I mean distance from I to j, and dk minus 1 ik plus dk minus 1 kj, I to k then k to j. In this way we are calculating the distance. If we talk about the example, then in this example we have here a graph. Total 3 nodes are given, node 1, node 2, node 3, and we have drawn here a matrix, 3 by 3 matrix, because we have here total 3 nodes, 1, 2, 3, 1, 2, 3. Distance, initially we are computing d node, I mean direct distance without involving any intermediate node. Distance from 1 to 1 is 0, because same node to same node distance is always 0. 2 to 2, 2 to 2 distance is 0 further. 3 to 3 distance is 0. When we talk about distance from 1 to 2, 1 to 2 distance is given. This distance is 4. We have marked 4. Similarly, distance from say 1 to 3, this is 5. We have marked 5. Distance from 2 to 1, this is 2. 2 to 2 further 0, and 2 to 3 distance is here. 2 to 3 distance, no as is available from 2 to 3. Therefore, we have marked here infinity. And 3 to 1 further here, no direct as is available. We have marked infinity. 3 to 2 here, 3 to 2 distance is here minus 3, and minus 3 we have marked. 3 to 3 distance is 0. We have mentioned here distances from all the pairs without involving an intermediate vertex. When we talk about here next matrix here we are using the B, I mean which vertex we are using as the intermediate. Here we are not talking about any intermediate vertex, therefore all the values we have marked 0. In the step 1, we are using here k equals to 1. I mean up to 1 vertex may be intermediate vertex. D naught we have already calculated. Now we are computing D1. To computing D1, our formula is, say, for example, we are computing the distance from node 2 to node 3. Then we have to write the formula minimum D naught 2, 3, D naught 2, 1 plus D naught 1, 3, D naught 2 to 3, D naught 2 to 3, this value is here infinity, infinity we have marked. D naught 2 to 1, 2 to 1, this value is here 2, and D naught 1 to 3, this value is 5. If we add 2 plus 5, this value is 7. Minimum of infinity and 7 is 7. Therefore, D1 to 3 we have marked 7. One more value we are showing here. This value is D132. D132 equals to minimum D0 32 d naught 3 1 plus d naught 1 2. D naught 3 2 is given here. D naught here 3 2. This is here minus 3. We have marked here minus 3. Similarly, D naught 3 1. D naught 3 1 is here infinity. If we take about the minimum, minimum is here minus 3. We have marked here minus 3. D1 3 2. This value is here minus 3. So in this way we have shown here two different values. All remaining values are computed in this way. If we talk about here intermediate vertex table, here we have shown this is here 1 because vertex 1 we are involving as the intermediate vertex. 2 to 3 we have involved vertex 1 as the intermediate vertex because k equals to 1. Therefore, we have marked b equals to 1. If we talk about the next step, the next step is here k equals to 2. And if we talk about k equals to 2, further we have shown here d1 table that we have computed just now. Now we have to compute d2. D2, for example, we are showing here D2 1 3, then D2 1 3 equals to minimum D1 1 3, D1 1 2 plus D1 2 3. I mean up to two vertices 1 and 2 may be here intermediate vertex. Therefore, minimum 5, 4 plus 7, minimum of these values are here 5. D2 1 3, this value is here 5. We have shown here D2 1 3, this is 5. Further here we have computed D2 3 1. If we place these values, then D2 3 1 equals to minus 1. We have placed D2 3 1, this is here minus 1. If we talk about here intermediate vertex, then in this case vertex 2 is our intermediate vertex. Therefore, we have marked 3 to 1 is 2 and it 1 we have already computed in the previous table. If we talk about next step, this is here our final step k equals to 3 because total number of vertices are here 3. Therefore, we have to go up to k equals to 3. If vertices are 10, then we have to go k equals to 10. If vertices are 3, then we have to go up to k equals to 3. If we talk about further computation, then say here we are computing D312. I mean up to 3, 1, 2 and 3. All nodes may be here intermediate vertices. Then D312 is given by minimum D212, D213 plus D232. If we compute this value, then this value is 2. Therefore, D312, this value is 2 and we have marked here this value is 2. And further we are showing one more value. This is here D321. We are putting here all the values, then minimum is finding here this value is 2. Therefore, D321 we have computed here D321 and this value is here our 2. 2 is written here. We have computed, we may compute all remaining values based on these formulas. Then if we talk about this value, this particular vertex, vertex 3 was here our intermediate vertex. From 1 to 2, we have taken k equals to 3 and it was our intermediate vertex. Therefore, we have placed here k equals to 3. So this is here our final solution. Distance from 1 to 1 is 0. Distance from 1 to 2 is 2. Distance from 1 to 3 is 5. Distance from 2 to 1 is 2. Distance from 2 to 2 is 0. 2 to 2 is 3, 7. 3 to 1 is minus 1. 3 to 2 is minus 3. 3 to 3 is 0. All the distances, we have find out the distance for all the pairs of vertices. And this particular table tells us what intermediate vertex we have involved here. I mean, distance from 1 to 2 is 2 and intermediate vertex was 3. Similarly here, distance from say 3 to 1 is minus 1. In this case, intermediate vertex was 2. which it was intermediate vertices, which vertex we have involved. We are drawing this computation from the B, and D tells to you about the minimum distance. In this way, we can solve the shortest path, all pair shortest path problem using Floyd-Warshall algorithm. Thanking you.